Problem 113, which is the last one of the first unit. Find the supremum and infimum, deciding whether they are the maximum and maximum respectively of the following sets. Okay, so let's start with A. Well, if you remember, the supremum is the number that so it's the smallest upper bound of a set, and the infimum is the greatest upper bound of a set, but there's no guarantee that both the supremum or the infimum will belong to the set themselves. Okay. So A is the set that contains -1 and the half closed, half open interval from 2 to 3. Okay, so it's clear that the smallest number in A is -1. Okay, so that the infimum of A will be -1. Okay, there's no, so that's the greatest lower bound, yes, and in this case it also belongs to the set, so this means that this is the minimum of A. Or you could think about it the other way. If a set has a minimum, in this case A has a minimum which is -1, then the minimum is up to automatically the infimum. Okay, and in this case the supremum of A is 3. Okay, the supremum of an open interval is just the number that where the open interval ends. Okay, because there's no so if you think about any number 3 minus epsilon, it doesn't matter how small epsilon is, it will belong to this interval. Okay, because it's smaller than 3. But the smallest number that doesn't belong to 3 already is 3. So this interval is 3. Okay, that's just the definition of the open interval. So we have that, and yeah, and 3 doesn't belong to A, so A doesn't have a maximum. Okay, so you could say, well, let's have 2.999 could be a maximum. Well, I can always say 2.9999, and I could always give you 99999. Okay, and I'll on and on until infinity. That's the weirdness of the real numbers. You could keep writing 9s up until you want, and then you could add another 9, and it will always be in a greater number that's not the maximum. And you could say, well, you could keep writing 9s up until infinity, but then you can prove that if you keep writing 9s up until infinity, then this is the same number as 3. Okay. So let's go for B. B is the set that contains 3, 2, -1, and every number between 0 and 1. Okay, so the minimum of B is clearly -1, which is the infimum as well. As I told you, if you have a minimum, you have an infimum, and the maximum of B is 3, which is the supremum. Okay. Sorry. So that was easy. Now let's go for C. C, let's start writing some numbers. C, when n is 1, so all naturals, so that's 3, and then 2 plus 1/2, 2 plus 1/3, 2 plus 1/4, and so on and so forth. Okay, so it's clear that this is a decreasing set in the sense that every number is smaller than the one before. So the greatest number in C is 3. So that's the maximum of C, 3. And because it's the maximum, it's already the supremum. Okay, and now is there a minimum to C? Well, obviously there isn't, because you can keep adding. If you choose one n to stop, then you could keep going on and choose a bigger n such that this number will be smaller. So there's no minimum to C, but there's an infimum, because if the limit of this sequence, as we will see later on, as you keep increasing n, this number gets smaller and smaller and smaller and smaller, and until in the limit it becomes 0. So the infimum of C is 2. Okay, so that's the greatest of the lower bounds of C, and there's no greater number than 2 that is not included here. Okay, that's the well, it's not that it's not included, sorry, that's that if you sum 2 plus some epsilon, that you can always find some n such that let's see, this is smaller than 2 plus epsilon. Okay, so the way to choose this is that this is if you choose n so that this is greater than 1 over epsilon, then you will have a number such that it's smaller than this, and it still belongs to C. Okay, so this will not an infimum. Okay, and this is true for every epsilon you choose, so that's why we know that the infimum of this is 2. Okay. Now for D, we can, so this is n squared plus 1 over n for all natural numbers. We can write this like n plus 1 over n. So this is clear that this is growing up to infinity. This is 1 plus 1, 2. So let's see, let's write it this. This is 2, and then 2 plus 1 over 2, and then 3 plus 1 over 3, 4 plus 1 over 4, and so on. Okay, so it's clear that this is growing. The minimum here is 2, minimum of t, and also the infimum. And the supremum, because there's no maximum, is infinity if you want. You could also say that there's no supremum because there's no upper bound, but also one way to write this is that if a given set has no upper bound, this is in this case the supremum is infinity. Okay. Now E is the set of all real numbers such that this parabola is below 0. Okay, let's find the roots of this parabola. And so we have x 10 100 minus 9 times 6, sorry, 4, and this is 36, and then over 6, so this is 8, and so it's 18 over 6 is 3, 2 over sorry, third, 2 over 6 is 1/3. Okay, so the true roots are like this. And so again, as usual, we have a parabola that has 2 roots, 1/3 and 3. It's a positive parabola, so that means that the tip is going downwards. So E is actually this interval from 1/3 to 3. So it doesn't have a minimum, it doesn't have a maximum because it's just an open interval. So the infimum is 1/3 and the supremum is 3. Okay, but there's no minimum and no maximum. Now F is the set of all numbers such that this product of 4 factors is smaller than 0. Okay, so this thing here with A smaller than B smaller than C and smaller than D is just a 4th order polynomial. Okay, so if we have A, B, C, and D, and let me write this correctly. So 4th order polynomials, if you go to numbers that are smaller than A, then every factor here will be negative, so everything is positive. So this goes like this, then goes like this, goes like this, and goes like this. Okay, not actually like this because I drew it like really bad, but you get my meaning. Okay, so F is actually the set from A to B, and then from C to D. Okay, that's all numbers between A and B will give you negative product here, and that's because, so if you're between A and B, that means this is negative, but this is positive, 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 so you have negative. And then if you have between C and D, you have positive, 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 negative, so then smaller than 0. All other combinations will give you positive products. Okay, so again, you don't have a minimum, you don't have a maximum. The infimum of F is A, the supremum of F is D. Okay, no minimum, no maximum. Now G is the set of all numbers such that you have this 1 over 2 to the p plus 1 over 5 to the q, given p and q natural numbers. So we can start giving numbers to p and q so that we can get some elements that are in G. But as you can see, as you increase p, this will go down. As you increase q, this will go down. So the greatest number in G is when you have p equal 1, q equal 1, and then you have 1 over 2 plus 1 over 5, and this is just 5 plus 2, 7/10. Well, this is the maximum of G, and also the supremum of G, 7/10. And as you keep increasing p and q, both of these guys will be going down until you get to 0, which is the infimum of G. Okay, so because as you can get as close to 0 as you want, but no number greater than 0 is lower bound of this, because you can also always get closer and closer and closer to 0. Okay, and finally we have H, which is the set that has -1 to the n plus 1 over n for n and m natural numbers. So let me do something. -1 to the n can either be 1 if n is even, or -1 if n is odd. So we have either 1 plus 1 over 1, 1 plus 1 over 2, 1 plus 1 over 3, and so on. And also you have -1 plus 1, -1 plus 1 over 2, -1 plus 1 over 3, and so on and so forth. Okay, so you have all possible values of m increasing here, and all possible values of m increasing here. So you have 2, and then 3/2, and 4/3, and so on. So, but the greatest number here is clearly 2, which is the maximum of h, and again the supremum of h is 2. And then you have the minimum here is you have 0. So sorry, this goes from 2, and then as you keep increasing, the limit of this will be 1. Okay, as m goes to infinity. And here you start at 0, and as you keep increasing, you end up in -1. But -1 is not an element of h. Okay, so in this case, -1 is the infimum of h, but it's not the minimum. Okay, there's no value of m that you can give to this expression so that you get -1. Okay, you could say, well, yeah, minus infinity, but infinity is not a valid natural number, so that's why we say that's in the limit of the sequence. When this is -1, it's -1 plus, and this goes to 0, so it's -1. But you can't never actually reach -1. Okay, so that's kind of tricky, but I hope you understand. And that's it.